Okay, so indirect measure is working with a little bit of geometry. We're going to actually be working with proportions, and we have done something similar to this before. But indirect measure is using similar figures to find a missing measure when it's difficult to find a direct measure. This is sometimes used like if I wanted to find, for example, here, the height of that tree. I could go through and measure the height of my person. So this is a 5-foot person. And I could measure the person's shadow, which was 4 feet. Now, if you look here, see how I'm actually creating a triangle? Okay, so indirect measure, they're just using the sun to create that shadow. So here I've got my tree that's a certain height, which I don't know what, and I have the shadow that's 30 feet. Okay, these are considered similar triangles. We don't have the angle measures there, but we know in indirect measure that they are creating a similar representation. So we can go through and actually set this up as a set of proportions to find the height of that tree. If we know that the shadow is 30 feet, I'm going to go ahead and just set this up as a proportion. Now, I like to take each scenario and set them up as a fraction themselves. So here I have the tree height, which I don't know, over my shadow. Now, if you had those flipped around, that's fine. But this was my shadow and this was my actual height. Okay, so then when I go to do the person scenario, I need to make sure that I put the shadow on the bottom, which was 4 feet. And the actual height of the person was 5 feet. Okay, so now we're going to solve a proportion. You can go through and say, well, what did they do to 30 to get 4? But that's kind of hard to see. The fastest method, cross multiply, divide. So you're going to multiply where you have those two diagonals. So 30 times 5 is 150. And we're going to divide that by 4. And when I do that, I get 37.5. So this is 37.5 feet tall. Okay, so that's working indirect measure, and we're reverting back to solving using proportions. Okay, so let's go ahead and try another one. Indirect measure, just where you can't actually measure it. So you're using another situation here. We're using the shadow to be able to measure it. Okay, so we have a flagpole and we have a shadow and then a person and a shadow. This time we're just working inches. Okay, so once again, we're creating a similar triangle when I connect the tops to the ends of the shadow. Okay, so I'm going to set it up as a proportion. I like to do each figure as its own fraction. So x over 90. Okay, this was my shadow. This was my actual. Okay, in my second scenario, the little girl was 54 inches. Over 36 inches. Okay, making sure that you're matching. So here I'm making sure that I have shadows on the same level. Now I'm going to go ahead, cross multiply, divide. So 54 times times 90, and then divide by 36. 54 times 90, divide that by 36. I get 135 inches for this. Now, if I wanted to change that into feet, I could do that. You guys remember how to change inches into feet? Remember our conversion, 135 inches equals blank feet. We practiced this at the beginning of the year. Okay, so my conversion is 12 inches equals 1 foot. And now I can cross multiply, divide. So I end up taking 135 divided by 12. And that gives me 11.25, which is 11 1/4 foot. So that's converting. I know this didn't ask us to convert it, but sometimes they may ask us to do that. So kind of tying in things that we practiced at the beginning of the year with those conversions. Oops. Okay, so here's a word problem. It says on a sunny day, if a 36-inch yardstick casts a 21-inch shadow, how tall is a building whose shadow is 168 feet? So if you're a visual person, you could draw like a really quick picture of this. So I've got my yardstick and the shadow. So the shadow was 21 inches. The yardstick was 36 inches. Okay, then I have a building. So here's my building. Those are windows. I know I'm a beautiful artist. And here it says a shadow of 168 feet. Okay, this one's slightly tricky. Here's why. What do you notice about these? we're working in different units. So we have to, in order to be able to go through and actually use proportions, you have to be working in the same units. So it doesn't matter which one you choose to convert to, if you want to convert it to inches or if you want to convert into feet. It's whatever your preference is. I'm going to go ahead and convert into inches, and here's why. I know that if I take that 168 feet and change it into inches, it's going to give me a huge number. So I would rather change each of these into feet. So that means I'm going to take 36 inches equals blank feet. And I know a lot of you can do this without writing it out, but I'm going to go ahead and show you visually for those of you that need it. Okay, my conversion is 12 inches. Remember, we match labels, equals 1 foot. So if I cross multiply, divide, that's going to now change this into 3 feet. Okay, so now I'll go ahead and do the same concept for the 21 inches. I'm just going to substitute in the 21 here. And I will have a decimal here, and that's okay. So 21 times 1 is 21. Divide that by, 21 divided by 12 gives me 1.75. And I'm going to write the 1.75. So I'm going to use those numbers instead. Now I can go through and use, okay, I can go ahead and use my numbers. So I have, this is X, I want to know the height. X over 168 is equal to 3 over 1.75. Matching shadow to shadow, the height to height. So now we'll cross multiply, divide. 3 times 168. And then divide that by 1.75. And that gives me 288, and we were working in units of feet. Okay, if you had gone through and worked this out of inches, we would just take that times 12. It would have been 3,456 inches. Okay, what most likely are you going to measure a building in? You're going to measure it in feet, not in inches. Okay, but because this was a small scale scenario, that's why they measured in inches there. Okay, and some of you might not need the picture. You might be able to just go directly into this type of a format, and that's okay. Make sure that if you choose to do that, that you are identifying the fact that here we were working inches and here was feet. Okay, all right, so let's go ahead and try another one like this. Says you plan to cross a river and you want to know how far it is to the other side. You take measurements on your side of the river and make a drawing scale. Explain why ABC and DEC are similar. And then what is the distance across the distance X across the river. So explain why they are similar to each other. So if we go through and look at this information, well, first of all, if they're similar, that means their sides are proportional. And also they should have the same degree measures. Okay, so here, when we look at this, we're kind of jumping back into something that we did back in section 2. And I'm seeing that I have vertical angles there, which means these are the same. So it doesn't matter what the angle measure is. If it's 58, then that means this one's 58. And I don't know what degree measure that is. I just know that they're equal to each other, which means these are equal to each other, which we already see. And that only leaves us with that third measure if we took 180 minus the 90 minus the 58. Now I'm just throwing 58 in there to give you that visual. So explain why they're similar. They have the same degree measures. Whoops, they have the same degree measures. Okay, so now it says, what is the distance? X across the river. So now we want to go through and find out this distance right here. The distance across the river. Okay, so we've got a triangle where on the right angle, making up the right angle, it is 60 by 50. And here it's 40 and X. I guess they marked X there, which makes more sense. I was going diagonal across the river. Okay, so now if we go through and we do this, well, I have 60 over 50. So I'm just taking that and writing it up. If you wrote it out as 50 over 60, that's okay. Now what we have to identify is the 40 is matching with which of these two here. That's where we're going to have to go through and identify. So if I were to take this figure right here and turn it so that my right angle was now on the left side, okay, this would be the bottom. So this would match the 50. So those two are similar to each other. So where I have 50, I'm going to have to write a 40. Okay, so sometimes they're going to take that triangle and they're going to turn it. So similar, when you have similar figures, they're going to turn them and you're going to have to match sides. Okay, so now I'm going to cross multiply, divide. So let's see. 40 times 60 and divide that by 50. It gives me 48. So it's 48 feet across the river. Okay, so that's just taking it up a notch using those indirect measures. Okay, so now I'm going to go ahead and write a couple up for you to try independently on your own. Okay, so I want you to try this one. If I have a tree, I know, a beautiful tree, and then I have a person here. And this person is, we'll say, 6 feet tall. And their shadow is, we'll say, 8 feet. Okay, I want you to find the height of this tree. So we have the height of the tree, and we'll say that the shadow is, let's say 30 feet. Okay, now you may get a decimal number on this, and that's okay. So go ahead and pause your video, and I want you to solve for X, the height of that tree. Okay, whoops. You should have ended up with 22.5. I'm just double checking myself. Yep, I got 22.5 feet for the height of that tree. Okay, so that's working indirect measure. If you have to draw the picture, you can draw the picture. Sometimes they're going to give you word format, so you might be comfortable just having to draw that picture. Otherwise, yes, I know some of you can go directly into creating your proportions off of that. So to solve for a direct measure, once again, those are similar figures when you have direct measure, and you can use proportions to solve for those. Okay, key things to remember out of this lesson: similar figures will always have the same angle measures, and their sides are proportional to each other. Similar figures are not exact copies. They're like a shrunk down or an enlarged version. Good luck with this lesson.